Trig. Okay, copy all this down, pause and copy, and you will have to memorize these, of course. I should say, I'm given the Leibniz notation here. It's also can be written using the prime notation. I'm saying that sine x prime is cos x. So let's look at a proof of number one. So proof. So let's start by saying let f of x equals sine x. Then the derivative is given by this limit, which we memorized so long ago. All over h. So in our case, f is sine, so we get sine of x plus h minus sine of x all divided by h. Then we're a bit stuck, aren't we? Well, this is sine of a sum of two angles. There's a formula, a trig identity, if you will. So this is something we don't typically have you memorize, but you can if you want. So this is sine x cos h plus the other way around, cos x sine h. So I'll use that formula to get something more palatable. Sine x cos h plus cos x sine h. Still minus the sine x there. All over h. Now I'm going to cry. No, I won't cry. I will say, whoa, look, that has a sine x and that has a sine x. Let's put them together and see what happens. Big bracket. So if I take this guy and this guy, put them together, what do you get? What do you get? You get sine x, right? Factored out, times cosine of h minus 1 over h. And then the other term, we'll have it as cosine of x times sine h over h. Okay, so again, this guy, let's get this cleaned up a little bit. This guy and this guy ended up giving me this term here. And then this guy went there. I'll put arrows here if you like. May help you see what's going on. Anywho, why did we do this? Well, look what has appeared. This and this are actually limits, or the limit of these fractions are things we saw when we looked at limits. The limit of this one is 1 over here, and the limit of this one over here is 0. Now, doesn't that work out nicely? So we get 0 plus cos x times 1. So we get the cos x that we were so hoping for. Now, if you want to prove the other ones, let me see, cosine, you can use a similar technique. And then tan, I would say, I would take a more direct approach, or I would use the fact that tan x is sine x over cos x, and then do a quotient rule. So I use a quotient rule there. You can do the same game for 4, 5, and 6 as well. So if you're looking for a challenge, why don't you assume that 1 and 2 are true? So use 1 and 2 to prove 3, 4, 5, and 6.